We're going to look at number 2 in section 4.5, which is to state whether L'Hopital's rule applies or not. So remember, when we talk about L'Hopital, there's certain times when it applies and when it doesn't. And what does that mean? Well, when we're looking at this limit, the question is it indeterminate of the form what? 0 over 0 or infinity over infinity. One of these two forms would be, excuse me, L'Hopital rule form, and then we can apply it. So let's see. Just a little note here, they've got the square root of x cubed. Square root of x cubed is the same as x to the 3/2 power, right? Third power, because we're cubing it, and then the square root is the 1/2 power. So it's literally it's x cubed then raised to the 1/2 or x to the 3/2, which I can also write as the square root of x and then cube it. In other words, I can cube x first and then square root, or I can square root and then cube it. I'm going to think of it actually this way. So when I look at this limit, what's the form of this limit? I'm going to rewrite the square root of x cubed as the square root of x quantity cubed. So now I plug in 81. I got the square root of 81 up here, plus 81 minus 72, square root of 81, and then cube it minus 729. Square root of 81 is 9. And so I've got 9 cubed. What's 9 cubed? Well, you can use your calculator if you don't know. It's 729. And so notice up top, I get 9 plus 81 minus 72. That's 18. But here in the bottom, 729 minus 729, that's 0. Notice that's not L'Hopital rule form, right? It's not 0, 0, infinity, infinity. So the answer to this question, does L'Hopital rule apply? The answer is no, it does not apply. Now, what is this limit? This is not part of the problem. You don't have to find the limit, just determine whether L'Hopital rule applies. What is this limit? Well, anytime you have a limit of this form, some non-zero number divided by 0. Again, this is what the limit is approaching. The limit says find all values, right, that are close to but not equal to 81. As we get closer and closer to 81, we're getting closer and closer to 18 divided by 0. We never get there. The question is what's happening? Well, bottom line is the top is very close to 18. The bottom is close to 0, getting smaller and smaller, very close to 0. And something close to 18 divided by something going to 0, overall, that's going to blow up, right, in absolute value. And so what we have at 81 is the graph of this function. If we were to graph this this ratio right here, this function, then we would see we'd have a vertical asymptote. In fact, you can kind of see if we approach 81 from below, we're a little bit less than 81 here, then the square root of that number will be a little less than 9, and 9 cubed would be a little less than 729. So this difference getting close to 0, but it would always be negative, right? So we'd have 18, I would say, maybe over 0 from the negative side, and that's going to negative infinity. If, right, a positive divided by a negative, right, going to negative infinity. On the other hand, if I approach 81 from above, then we're slightly bigger than 81 here, slightly bigger than 9, and then that value cubed would be slightly bigger than 729, and this difference now would be positive, and we'd have 18 divided by 0, but we're approaching 0 from the positive side. Positive divided by positive, that's positive infinity. You could also see this just numerically. If you notice I put this actual function here, square root of x plus x minus 72 in parentheses divided by the square root of x cubed, I just wrote it that way, minus 729 in parentheses. And then if I go, my table is set up to ask mode for the independent variable. And I come over here, let's get close to 81 from below, from the negative side, which I said was, the limit was negative infinity if we approach 81 from the negative side. So what's something below 81? How about 80.5? 80 and a half is below 81. Can we get closer? Yeah, 80.9 is closer to 81. Can I get closer? 81.99. Can you get me closer? 81.99. No, I'm sorry. I went too far, didn't I? Not 81, I'm at 80.99, sorry. 80.999, I passed it. Now, notice what's happening as we get close to 81, right, from below, then these values, notice, are blowing up, but they're always negative, right? By the time we get to 80.999, which is a small change in x, we've jumped from negative 133 to negative 1,333. So this is, quickly dropping down, going down as we approach from the left. Similarly, and so I could write the limit as x approaches 81 from the negative side of this is negative infinity. Similarly, we can find the limit as x approaches 81. I said it would, from the positive side, I said it would be positive infinity, and you can do that numerically as well. Above 81 would be like 81 and a half. 81.1, that's above 81, but closer. Can I get closer? 81.01, 81.001, and so on. And you can see the values are always positive, but they're blowing up. They're getting larger and larger in absolute value, so we're going to positive infinity. And I can write that way. Since the left limit and the right limit are not the same infinity, they're not both infinity or minus infinity, here we would say the limit as x approaches 81 of this does not exist. So we can't use L'Hopital's rule to do this particular one, but we can go back and do what we did with infinite limits earlier in the semester. Okay, I hope this helps with this one. Again, if we are able to get one of these two forms, then we would state that L'Hopital's rule does apply.